All right, guys, here we go. Lesson 13, and I'll be doing lesson 13 on graph paper. I would suggest using graph paper as well when it comes to graphing. All right, so lesson 13 is on graphing linear equations. This should be review. Now, they mentioned three methods, but I'm only really going to cover one because I only want you can use any method, but I think there's only one that's the easiest. So three methods that they go over is building a table, finding your intercepts, and third, slope-intercept form. Now, I don't care which method you use. I would prefer slope-intercept. It's the easiest, fastest. It carries over into the next class, and we use it all the time. So that's really the only one I'm going to go over. But if you use a different method on the homework or test, that's fine. Building a table isn't very effective, especially when it comes to solving systems. So I wouldn't bother. Finding intercepts are the main two. But like I said, I'm only going to go over slope-intercept. So here we go. So again, if in homework and it says graph building a table, you can ignore them and then graph using this method. So I will write that. Okay. So slope-intercept form is when we put an equation into this form. Y equals mx plus b. Now, I'm pretty confident you probably know what m and b stand for. M represents our slope, which equals our rise over run. B represents our y-intercept. Now, please, a y-intercept means it's on y-axis. Do not put your y-intercept on your x-axis. Just silly, silly, silly. So here we go. Example number 1. Graph y equals negative 2x plus 1. All right, so in this equation is already in slope-intercept form. So just looking at it, I know my slope is negative 2 over 1, and I know my y-intercept is at 0, 1. So we can go straight into graphing. So here is my y-axis. Here is my x-axis. You don't have to label every number, but please throw some numbers on there. Okay, so my y-intercept is here. I hope you guys can see that. If not, I'll make that really apparent. Okay, so you're going to plot y-intercept first, then rise over run. Whoops. And you're going to go from the point. So from this point, it's negative 2. So I'm going to go down 2 over 1. Down 2 over 1. Let me grab a pencil so you can see that. Or if you're watching my video, I went down 2 over 1. Down 2 over 1. Okay, now you can do this in the opposite direction, so going back to the y-intercept, go up 2 and to the left 1. And the reason I did that is because it has a negative slope, so the line needs to be pointing down. So, and I should have gone over that. Lines that look like this have a negative slope. Lines that look like this have a positive slope. Okay? All right, so there's example number 1. And I can go rise over run in either direction, up and to the left or down and to the right. So, next one. So here we go. And I want to make sure I did examples of both. So graph 3x minus 2y equals 6. Now, I need to put this in slope-intercept form. So in order to do that, I'm going to do the following. So I'm going to rewrite it. I'm going to subtract 3x because I need to get y by itself. So I have negative 2y equals negative 3x plus 6. Notice I wrote the right-hand side in order. Then I'm going to divide everything by a negative 2. So I'm dividing each term. I hope you can see that. I'm dividing each term by what's in front of y. So this is y equals 3 over 2x minus 3. So here is my slope. Slope is positive 3 over 2 and negative 3. That right there is my y-intercept. So that's at 0, negative 3. So I'm going to draw. There's my y-axis. I need to leave room for negative 3. Negative 3 is down here, so I'm going to put my x-axis a little above. So there's x, here's y, 2, 4, here's negative 6, 2, 4, 2, 2, 4. Sorry, my y looks kind of funky. Okay, so I'm going to move this up. My y-intercept, here's the y-axis. I even labeled it. There, right there, should be my y-intercept. It's on the y-axis. From there, now this is a positive line. Positive line, when you read them, going from left to right, they should go up. So, starting from here, I'm going to go up 3 over 2. Up 3 over 2. Then going back to my y-intercept, down 3 and over 2. So if you can't see that, I'm going up 3 over 2. Okay, on the last one, we went down 2 over 1. And then make sure when you graph, you have arrows at the end. Use a ruler, make it beautiful. Okay, next one. And then we will move on. So number 3. Okay, ready? X plus 2y equals 6. Sorry about that. Now, I need to get this in slope intercept form, which is y equals mx plus b. So to do that, I'm going to subtract x. So I get 2y equals negative x plus 6. Divide by 2. Remember, I'm dividing everything by a 2. So y equals, there's an invisible 1, so I'm going to leave it. plus 3. Okay, I hope you can see that. There's an invisible 1 right there. So here is my slope. Here is my y-intercept. So this is slope. Here is y-intercept. So here we go. Here is my y-axis. Here is, I'm going to leave room for positive 3, right? Positive 3 is way up here. Here's my x-axis. Here's y, 2, 4, 6. 2, 4. Notice I only label every fourth, but at least I have a number on there so you know that each box is equal to 1. So again, I'm going to start with my y-intercept. So on the y-axis, positive 3. Starting from my y-axis, this is negative. So I'm going to go down 1 over 2. Down 1 over 2. Going back to the y-intercept, up 1 and to the left 2. Up 1 and to the left. It's a negative slope, so I'm headed towards the negatives. So that should be my line. And arrows at the ends, please. All right, moving on. Again, there's other methods, and it goes over this in the book, but I'm just going to cover that one. All right, so the next part of our notes is calculating and identifying slope. So the first way we calculate it, right, how to find slope, m equals the change in y divided by the change in x. Now that is also review. Now why is it the change in y? Because y runs up and down. So it's your rise over your run. X runs left to right. So that's why it's the y values on top and the x values on the bottom. It doesn't matter if it's the second one minus the first or the first minus the second, but you're finding the difference. Now that's how this is how you calculate. So calculating slope looks like the following. Identifying slope. Okay, so we have 4 types. So I'm going to draw them. There's 1, 2, 3, 4. So on each of these, here's an x, y, x, y, x, y, x, y. So I'm going to draw the 4 types of slopes. 1, if it rises, we would call that a positive slope. Opposite of a positive slope would be if it falls. If the line falls, then I would say this has a negative slope. Now, then there is a horizontal line. And if it is horizontal, my slope is 0. The last possibility is a vertical line, so we call that vertical. And in this case, my slope is undefined. Okay? So the 4 types that we're going to be using in this section is that it could rise, fall, horizontal, or vertical. So I'm going to do a couple examples with you, and then we will do our lesson practice. So example 4. You are going to calculate slope and classify. Okay, and we're going to classify either as rises, falls, horizontal, or vertical. So part A, here are our points. -2, 3, -1, 5. So the first thing I'm going to do is calculate. So slope equals, I'm going to grab my y values. So 5 minus 3 over -1 minus -2. So I have plugged in my y values and I'm dividing it by my x values. Be careful with your negatives, okay? It's -1 minus a -2. So put the second value in parentheses if you need it. I'm going to simplify that. 5 take away 3 is 2. This gives me -1 plus 2. So I get 2 over 1. So m equals a +2. So that means that my line rises. Okay, and that would be the answer. A calculated slope, it's positive, so I know that this line rises. Part B. My points are -4, -1, 2, -1. Now, if you don't want to calculate slope, notice my y values are the same. So if you were to picture this, it would look like this. It'd be -4, -1, and 2, -1, right? This is 2. This is -4. So that is a horizontal line. Or you can calculate. So m equals -1 minus -1 divided by 2 minus -4. Notice those parentheses I'm using. Okay, you need to do the same. So this becomes -1 plus 1 over 2 plus 4. So I get 0 divided by 6. So my slope is 0, and I have and it's horizontal. So if I get a slope of 0, remember, slope is 0, horizontal. Next one. Okay, you should be able to do this on a test because it's on there multiple times. So don't say you never saw this. 3, 7, -1, and 10. None of these values are the same, so I'm not going to picture it. So I'm simply going to calculate it. So 10 minus 7 over -1 minus 3. That gives me 3 over -4. So my slope is -3/4. So this line, because it's negative, falls. Last one, and then we'll do lesson practice. So 6, -2, 6, -3. Notice these x is the same. So if you were to picture this, so let's say this is 2, 4, 6. Ay, Michelle. So 2, 4, 6. Let's say this is -2. You'd have one here and one here, which means this is vertical. Or you could calculate it. So -3 minus 6, right? -3 minus 6. 6 minus -2. That gives me -9. Ha! This should be, I wrote it down wrong. How could I? I'm so sorry. I'm so silly. -3 minus a -2. 6 minus 6. This is 0. This is -1. That means its m is undefined. And so this is a vertical line. So let's jump into lesson practice, which is on page 90. And I might need more graph paper. So part A. Sorry, turning the page, turning the page, turning the page, turning the page. Part A is y equals negative 1/2 x plus 3. Pretty sure we already did that problem. It says to solve it by building a table, but remember I don't need to build a table. It's much easier if I just graph it. But this is accidentally one of the ones I did with you. So here's 3, down 1 over 2, up 1. Whoops. My eyes are playing tricks on me. This is 2. This is 4. There's my line. All right, B. B, the equation is negative x plus 4y equals 8. It said to use x and y intercepts, but I'm not. I'm going to keep it in slope-intercept form. I think it's much easier. So 4y equals x plus 8. Divide by 4. Remember, you can pause the video. Y equals, there's an invisible 1 right there. So 1/4 x plus 2. So here we go. 2, 4, x, y, x, y. So there's my y-intercept, up 1 over 4, down 1 over 4. And that is what it should look like. Okay. Then for the next 3, it wants us to calculate and identify. So the following points, negative 3, 5, and 5, negative 6. So I'm going to calculate slope first. Negative 6 minus 5. Those are my y values. 5 minus negative 3, there's x. So negative 11 over 8. Okay, so I have a negative slope, right? Slope, or m, is negative 11 over 8. So therefore this line falls. Okay, give me one more second. I don't think I need more graph paper, but I'm going to continue using graph paper. So I believe we're on D. The 2 points for D are 0, 4, and negative 2, 0. Okay, now it might look like there are things that are the same, but there are not, so don't be confused by that, because, yeah, they are not the same at all. Sorry, I'm organizing my work, and I'm doing a terrible job of it. Okay, so, sorry, this should be, all right, I'm fixing something on my notes, and then I will jump in. Maybe you can be calculating it. Okay, so for this one, 0 minus 4 over negative 2 minus 0. Whoops. Yeah, I'm making all kinds of mistakes today. That would give me negative 4 over negative 2. So m equals positive 2. So this line rises. E, the points I was given is negative 4, 3, and 8, 3. Notice those y values are the same. So if you can already picture it, you can write what the answer is, or you can calculate it. 3 minus 3 over 8 minus a negative 4. That gives me 0 divided by 12. So m equals 0, which means this is horizontal. And then F. F asks me to, sorry, I should do that, to identify slope and y-intercept. Easy peasy, right? Slope is 1/3. Y-intercept is 2. And that is it. Sorry, I have to unlock my screen. And I had a caps lock.